When when taking derivatives, we had a very important rule called the chain rule, and that basically went like this. If you have y equals x squared plus 5x plus 1 raised to the 7th power, let's say, and you're taking the derivative, then you'd have derivative of the outside function is 7 and then to the 6th. The chain rule then says leave the inside function alone for now, because you should only take the derivative of one thing at a time, and then take the derivative of the inside function, 2x plus 5. So if you're going backwards, then we would be given this problem right here and asked to integrate it. So with this one, we have whatever is here, the derivative of it is just outside being multiplied. Well, that's essentially what the substitution rule is doing. It says, okay, you're going to have the inside part right here, which for substitution we usually call u, and then via the chain rule, you need the derivative of it right out here. So the u should be the inside function. So with this one, it's inside of the square root, so that's going to be the u. So let u equal x squared plus 6x plus 1. And then take the derivative of that. So it's going to be the derivative of u is going to be 2x plus 6, and I took the derivative with respect to x. Well, this thing right here is supposed to be that right there. It's very close though. So what we need to do is manipulate this with a little bit of algebra, like you could factor out a 2, and it would leave x plus 3 dx. Now what we're going to do in this is replace all of the x information with u information. So we already have that this is going to replace that. And then notice this says, in your problem, you need to have an x plus 3 in parentheses and a dx. Well, it's got it. There's the x plus 3 in parentheses and the dx. So inside of the square root, that's going to be replaced with the letter u. The square root will still be there. And then this, as well as this, gets replaced with, well, we need to do one other job, and that is the 2 is not supposed to be there. So divide by 2 or multiply both sides by 1/2. So now it's set up perfectly for the u substitution. So we'd have the integral, like I say, the square root stays there, and inside the square root is just the letter u. And then replacing both of these is a 1/2 du. So constants that are being multiplied can be factored out. So I'm going to write the 1/2 du like this. And then to integrate this, I would rewrite the square root as the 1/2 power. And then for integration, you add 1 to the exponent and then divide by that number. So we're going to have a 1/2 already, and then u to the 3/2, and then divide by 3/2. And then plus a constant. So we need to invert and multiply, so instead of dividing by 3/2, you can multiply by 2/3. So the 2's are going to cancel, it's just going to leave 1/3. And one other thing is, the original question had x's in it, so the answer should have x's in it. So replace u with that polynomial. And that would be the antiderivative. Now, of course, we can always check the answer. So we'll take the derivative of this, And we should end up with that. So if we take the derivative of this, the 1/3 can stay there. Then the 3/2 would go down in front and multiply. It would then, if you subtract 1 from this, it would then be raised to the 1/2 power. And the chain rule says the derivative, excuse me, the inside part stays the same. And then we need the derivative of the inside. Oops, off the edge a little bit. And then the derivative of a constant is 0. So then, if we simplify this, the 3's are going to cancel. We would have the 3's cancel. We would have a 1/2. Well, notice that these two things could be cut in half. So if you take the 1/2 and move it over here, or take this 2x plus 6 and move it to the front, it's going to be, these get cut in half, so it's going to be x plus 3, and then x squared plus 6x plus 1 is to the 1/2, and that is exactly what we started with. So that means that it is correct.